In this video, I just want to show you that you can represent decimals in binary. Really, all I really care about you knowing is that it's possible to do this. You don't really need to know how to do this for this class, but just maybe you need some convincing that this is possible, and that's what I'm going to do here. All right, so let's start with a number in base 10. This is the normal way that you think of the number 5/8. 5/8 is 0.625. All right, so this is really just, this is shorthand here. Shorthand or just notation. This is really just notation. What this means is 6 times 1 over 10 to the 1 plus 2 times 1 over 10 squared plus 5 times 1 over 10 cubed. All right, so that's so when you write this, you actually mean this. This shorthand or notation over here means this number, this exact number here. All right, so now, okay, so this was base 10, right? This was base 10 up here. This was base 10. Now look at binary or base 2. In base 2, we do basically the same thing, same idea, except for we have things like, instead of 1 over 10 to the 1, we have some number, either a 0 or a 1, times 1 over 2 to the 1, plus some number, either a 0 or 1, 1 over 2 squared, plus some number, either a 0 or 1, times 1 over 2 cubed, and so on, forever and ever and ever. Okay, so 0.101, this is equal to 1 times 2 to the 1 plus 0 times 2 squared plus 1 over 2 squared plus 1 times 1 over 2 cubed. We can figure out what this is. Let's see, this is going to be, let's see, this is 1 over 2 plus 1 over 8, right? Because, okay, let's see, so that's times 4, getting a common denominator. You see that this is 4 plus 1 over 8, or 5/8. So here we have another way of saying the same thing. Notice here we had 5/8, here we had 5/8. Right, so we just have two different ways of saying the same thing. You can use it as long as you know the way you're representing things. Okay, so what I want you to see from this is that you can convert from base 10 to binary, and it's the same thing. And just as long as you know which system you're using, what your base is, you can convert things. All right, let's just do a couple more here. Let's see, how about 0.1. 0.1, this is 1 times 1 over 2 to the 1, otherwise known as 0.5. So 0.1 in base 2 is 0.5 in base 10. 0.01, we have 1, we have 0 times 1 over 2 to the 1 plus 1 times 1 over 2 squared, that's 0.25. Okay, so if you have, let's say we have an interval of real numbers between 0 and 1. Let's say this is in base 10. Let's see, we got let's see, 5/8, that's a little bigger than 4/8. So we've got, let's say, not quite to scale here, but anyway, 0.625 there, something like that. That it is possible, all I want you to see is that it's possible that you can convert all these numbers and they still mean exactly the same thing. All right, it's still 0.25 as you know it. It's still 1/4 as you know it. But we just write it as 0.01, 0.1, 0.101. That's right, and this is base 2. So you can do this, and it's still unique, because since all these numbers in here are unique, and these are just different ways of saying the same thing, everything in here is unique.